This was working 5 seconds ago. Oh, it's working.
Okay. All right, so it says factor and solve. So first of all, we have to say to ourselves, what kind of factoring are we doing here? It is quadratic. Notice it's degree 2. But we would not do a multiplies to be a times c adds up to be b, because from the beginning, it's much easier to just say, okay, what's in common? 2 and an x. Why isn't this writing? Just a second. This here. All right, so we factor out a 2x, and then we'll divide each term by 2x. So then left was 2's divide out, x squared over x is x. Positive 6 divided by 2 is positive 3. The x's divide out. And look, we're down to linear factors. Remember what linear factors means? This is really important. We're about to get into secondary math 3 stuff. And this is a teeny tiny piece to about every lesson, the first unit. So we have degree 1 and degree 1, right? Those are linear degree 1 factors. So the reason we factor is so that we can set linear factors equal to 0 and solve. So we have this factor, we have 2x equals 0. And we also have x plus 3 equals 0. Now it's just algebra, guys. It's just algebra to get x alone. 2 times x, what undoes multiplication division? Divide both sides by 2. 0 divided by 2 is 0. So x equals 0. It's crossing the x-axis at 0. We would subtract 3, x is equal to negative 3. And it's also crossing the x-axis at negative 3. We could have checked our answers by graphing this and looking with our eyes, solving by graphing to see where it crossed the x-axis. Because didn't they cross that whole number of places? Does everybody understand? Do we have questions? Okay, awesome. All right, so I just want to do some review. Today is the test review. There's some stuff I want to go over before I just set you free to work on the test review. So I don't answer all of them individually. I just tell you all at the same time. So everybody look up here for a second. If I said solve, 2x squared minus 3 is equal to 0. We're solving the quadratic. Aren't we finding the x-intercept? But there's appropriate ways to do this and not so appropriate ways. So first of all, aren't we missing the middle value bx? Quadratics have the form ax squared plus bx plus c. I'm trying to help you see how you would solve this on the test. That's going to be next time. Do you see how we do not have a middle value bx? We would solve by taking square roots. So we isolate the square. That's what we have to do first. So we'd add 3, correct? So we have 2x squared is equal to 3. Then what would we do next? Would we square root it yet? No, we've got to isolate the square. Divide by 2, divide by 2. So we have x squared is equal to 3 halves. My next step would be to square root both sides of the equation. Root cancels out with power. Now, don't forget the plus and minus, correct? Quadratics always have 2 solutions. You better have 2 or you've done something wrong. Now, remember, if you ever have division, 3 divided by 2 does not simplify. So we would split it up. We have x is equal to the square root of 3 over the square root of 2, plus and minus in front. Is this an appropriate answer? Why not? We can't have a square root. We can't have a root of any kind in the bottom. So we're going to rationalize the denominator. So I'm going to multiply by the square root of 2 over the square root of 2. Now you multiply straight across. So on top, don't we have 3 times 2, which is square root of 6, all over the square root of 4, which is 2. Now we fixed it. Can I divide this, what's under the root, with what's not? No, there's our 2 solutions. Questions? Okay, looking at this one, remember, stuff like this will be on the test. If I said find sine of theta, isn't sine, oh heck, opposite over hypotenuse? Doesn't our saying go, we would write it down on the test when I hand you out a blank test. It's not considered cheating if from memory you were to write on the top, oh yeah, I need to remember sine of theta, cosine theta, and I would always do this on my ACT, tangent theta, and then the saying goes, oh heck, another hour of agony or Sakatoa, whatever you go for. So it says sine of theta, so we're simply finding sine, correct? This is where people usually mess it up. We're just finding sine, right? Sine is, oh heck, so go to theta. Oh, opposite over hypotenuse, oh heck. Don't we have both of those things? Okay, awesome. If we didn't, we would look on the side and say, okay, can we use the Pythagorean theorem? But we don't need to for this one. So we have the square root of 2, which is opposite, all over 2 square roots of 5, hypotenuse. That is sine, right? We're not going to go inverse sine. We're not finding theta. We're asked to find sine of theta, and we did that. However, is this answer considered simplified? No, right? We can't have a square root on the bottom of a fraction on a test. I will mark it wrong if you don't rationalize the denominator. Square root of 5 over the square root of 5. So on top, 2 times 5 is the square root of 10, correct? And on bottom, we have 2 square roots of that becomes square root of 25, which is, so 2 times 5 is, so our answer is the square root of 10 over 10, and done. Questions? Okay. Next thing, super important. I just want to make a point here because all of you, most of you are juniors and you're going to take the ACT and it's multiple choice. And if you are solving for something, you've got to be able to see if your answer is the same as another answer correctly. So everybody look up here. Just looking, just glancing at these, they might not look like they're the same answer, but they are. Now here's why. Okay, so let's be really careful as we do this. I want to rewrite this one in standard form. So right now it's not in standard form because G would come before 2, like the highest degree to lowest degree. So let's reorder this correctly, you guys. This is just to help you, and I might say, what is this equal to? What does this technically simplify to be, this piece? So on top right now we have a -1. I'm just rewriting the bottom. That's negative G, correct? That's plus 2. Now remember, we've been factoring, and remember, if there's ever a negative in the front, so you have to think a little bit more advancedly, if there's ever a negative in front, we are going to factor out a negative. So once again, just focusing on the bottom here. So on top we have -1. Now on bottom, just looking at this negative G plus 2, I'm going to factor out -1. Now don't we go and divide each term by -1? So that would be positive G. Positive 2 divided by -1 is -2, correct? Now looking at that, we can always divide out multiplication. Isn't -1 over -1 positive 1? So we have 1 over G minus 2. Do you see how these are the same? They look pretty dang different, but they are the same. Yes? We're all good. So let's do another one. On an ACT, if you had this as your answer, and I did not, let's say I gave it as multiple choice, and you're like, I don't see that answer. Well, then you should say to yourself, it must simplify. So once again, they will write it in standard form. Is the bottom in standard form? No. So let's rewrite it in standard form. Won't that be -x plus 3? Once again, if there's a negative in front, we'll factor out a negative. So we're factoring out -1, divide each term by -1. I'm ignoring the top for a minute. That's positive x minus 3, correct? So on top we have -4, and on bottom we have -1 times x minus 3. Doesn't a negative over a negative become positive? So this is actually how they would write it on the ACT, 4 over x minus 3. Do you have questions on that? We're all good with seeing that? Okay. We need your ACT first to come up. Okay, complex numbers. This is a secondary math 2 topic. If you want to get out your last time's worksheet, your quadratics, we're going to finish that up real quick. So guys, complex numbers are numbers with real parts and imaginary parts. So they have the form a plus bi. This is the important part. You write the real part first and then the imaginary part second. So no matter what, our final answers are always written in a plus bi form, where a is the real part and bi is the imaginary part. So these are all just examples, guys, of complex numbers. -2 plus 3i. -2 is the real part and 3i is the imaginary part. This is a complex number. 5 is the real part, -2i is the imaginary part. 3 technically is considered a complex number. That's just 3 plus 0 i's, correct? So technically that's also, any number is considered a complex number. 5i is a complex number. That's 0 plus 5i. So basically every number is a complex number. So let's do complex numbers and addition and subtraction. So with these, you add real parts with real parts, imaginary parts with imaginary parts. Technically, we're combining like terms. So here we go. Worksheet 2-5, all my examples are coming off that. Number 25. Now here's what tricks people. Guys, you really got to pay attention to what I'm about to say so you don't miss on the test. Just because these are in parentheses doesn't mean it's multiplication. We have this complex number plus this complex number. Does everybody see how you really have to look? so you don't start multiplying these. Yes? Okay. Now we'll combine real parts with real parts and imaginary parts with imaginary parts. With addition, we don't have to be careful. We can just combine like things. 8 plus negative 8 is 0. 3 i's plus negative 7 i's. Negative 4 i's. So our final answer would be negative 4 I. That's simple. It's just combining like terms. 26. Once again, there's parentheses here, but then these are addition and subtraction. It is not multiplication. So we're simply combining like terms. Combining real parts with real parts, imaginary parts with imaginary parts. Negative 2 plus 4 is positive 2. 2 minus 7 is negative 5. So we just took care of those. And then we have plus 2i, no other i's. Yep. Pretty simple, right? You will have these on the test. Here we go. So looking at this one, there's some multiplication here and some addition. So look, we have negative 4 times all that stuff, and then we have positive 6 times that, correct? Let's distribute negative 4 through carefully so you don't miss it on the test. Negative 4 times negative 1 is positive 4. Negative 4 times negative 7 i's is positive. A negative times a negative is a positive 28i. You've got to pay attention to the little details. Does everybody understand why it's positive 28i? Okay, then positive 6 times negative 3i's is negative 18i's. And now we'll combine real parts with real parts, imaginary parts with imaginary parts. So we have a 4. And then 28i's minus 18i's is positive 10i's. You always need to write your answers in A plus BI form. It's not considered simplified if you wrote 10i plus 4. I'll mark you off a little bit on the test if you don't write it right. Okay, number 30, this is subtraction. I promise you there will be a subtraction one on the test, and I promise you 90% of students miss it. Here's why. You need to, notice this, subtract all of this. You need to, please, I'm begging you, just put in a negative 1, and multiply it through. And then you'll rewrite it down here and not have to worry about the negative. So negative 1 times positive 8 is negative 8, correct? You've got to distribute that negative through over here as well. Negative 1 times negative 6i's becomes positive 6i. And now you can just drop down the front things. You wouldn't change signs on this. There's not a negative in front. You'll just drop these straight down. So we still have negative 7 minus 2i. Does everybody see how I did that? Yeah. Now real parts with real parts, imaginary parts with imaginary parts. Negative 7 minus 8 is negative 15, correct? Negative 2i's plus 6i's is positive 4i's. Questions? Okay, doing good. All right, so I want you to recall something. Back to secondary math 2. The square root of negative 1 is I, right? Just like when we were pulling out an I when we were simplifying underneath the square root and there was a negative. Well, if that's true, I want you to look at the math. If I wanted to get rid of the square root, don't we square both sides? So then look, root cancels out with power. Thus, negative 1 is equal to I squared. Negative 1 is equal to I squared. So if you ever see I squared, literally you re-switch it in with negative 1. They're the same thing. They're equal. I squared equals negative 1. All right, so let's multiply complex numbers real quick here. So looking at 27, very, very carefully, and we're going to be smart about this. Notice it's this times this, correct? Let's multiply those together. What's 2i's times 7i's? 14 I squared. I times I is I squared, correct? Then careful here, we have negative 3 times all that stuff. Let's distribute that through. So we're going to have minus 15. Negative 3 times 5 is negative 15. And then negative 3 times positive 2i's is negative 6i's. Anytime you have an I squared, you know I squared is literally equal to negative 1. So look up here. Isn't this 14 times by times by I squared? Right? Yes. So isn't that the same thing as 14 times negative 1? Yes, which is negative 14. So really we have negative 14 minus 15 minus 6i. combine real parts with real parts, imaginary with imaginary. Negative 14 minus 15 is negative 29, right? Minus 6i. So you've got to change anything with an I squared to negative 1, and make sure you don't add it. I always have students in secondary too, but your brain should be more developed now. Understand that that's not an addition sign, it's multiplication. 14 times negative 1, not 14 plus negative 1. Questions? Okay, let's do another one off the worksheet. 29. All right, looking at 29, we have all this stuff multiplied to all this stuff. That's going to be a double distribution problem, right? So very carefully draw in your arrows as you go. Negative 5 times negative 3i. Very careful. There will be one like this on your test. Positive 15. Now negative 5 needs to be multiplied to negative 3i. Positive 15i's, correct? Now I'm going to go underneath here and I'm going to say, okay, we have negative 8i times negative 3i. Positive 24i's. Good. And then we have negative 8i times negative 3i. Good, 24i squared. Does everybody see? That's where most people mess up. They don't do the I squared. So really, don't we have 24, positive 24 times negative 1? Right? So that's really negative 24. So now real parts with real parts, imaginary parts with imaginary parts. 15 minus 24, somebody calculate that real quick. 15 minus 24.
9.
Negative 9?
Okay.
Negative 9, right? If you wrote positive 9, we'd be off, almost. Negative 9, and then we can combine our i's. 15 i's plus 24 i's is 39 i's, right? Positive 39 i's. A plus bi form. Are we all comfortable?
Yeah.
Okay. Awesome. So with 32, we would multiply a negative 7i to both of those, right? So that'd be negative 35 i's, and then it will be negative 35 I squareds, correct? Negative 7i times positive 5i's. And then right here we distribute that negative 5 in, so we'll have minus 5 plus 25 i's. So then combining, let's change our negative 1 first. So really we have negative 35i, and we have minus 35 times negative 1. Which won't that be positive 35? So real parts with real parts, imaginary with imaginary. So we've rewritten that, we've rewritten that. So 35 minus 5 is 30, correct? And then we have negative 35i's plus 25i's, which is negative 10i's. A plus bi form. Does everybody get it? Because if you don't, please say and then I can explain. Yes. Okay. Sweet. Okay, worksheet, grab your, we're not going to go over that. Okay, grab the test review for today. I'm going to go over some because we did not touch on this day that we solved linear equations and you could see this. Let's do number 1 together. If I said solve the equation, don't we combine, aren't we solving for the variable? Okay, so we're solving for x. So we have x plus 2x minus 4. So let's combine like terms, right? Won't that be 3 x's? Minus 4 equals 11, correct? Now it's just algebra to get x alone. So we'd add 4. So we have 3x is equal to 15. And we're just solving for x. Next step, divide by 3, x is equal to 5. Is everybody comfortable with that one? Okay, let's do number 2. It's something we haven't seen since last year. If I said solve for x, we've got to combine x's, but we've got to use algebra to get from one side of the equation to the other. So I'm going to subtract x. Now look, won't that be 0 over here? X minus x is 0, which is equal to 0 plus 2, right? X minus x is 0, plus 2. So don't we get 0 is equal to 2? Is that a true statement? No. So we would say no solution. Our x's went away. It wasn't a true statement. That's not true, so we would say no solution. Literally, you can't solve for x. You will never be able to plug in numbers and make this a true statement if you plug in the same for x. Okay, number 10. we have 2x plus 5 is equal to 5 plus 2x. Solving for x, we'll combine our x's using algebra, subtract 2x, subtract 2x. So won't that be 0 plus 5 is equal to 5 plus 0? 5 is equal to 5. Is that a true statement? Yep, so that would be all real numbers. Any number we plug in for x, if we plug in a 1 and a 1, it's going to be true. It's going to be a true statement. If we plug in 2, it's going to be a true statement. So our answer would be all real numbers. If it's a true statement, then any number we plug in that's a real number will be a true statement. Questions? Okay. We're almost done. Number 19, and then I'll give you the rest of the time to just work on that test review. Here we go. Number 19, if it says, these are literal equations. So it says solve for y. Solving for y. So first of all, don't I have this 3/7 multiplied in front? Okay, I want you to think about this like this. Okay, we've got to be really good at algebra and secondary math 3. So I want you to think of it like this. Isn't this 3 divided by 7? What undoes division? Multiplication. So I'm going to multiply both sides by 7 first. 7's divide out. That leaves me with 3 times y plus 2 is equal to 7g. Does everybody understand why I multiplied by 7? Now to get y alone, my next step would be to undo that 3 that's multiplied to all this. So when I divide by 3, so we have y plus 2 is equal to 7g over 3. And then last step to get y alone. Subtract 2, subtract 2. So we have y is equal to 7g all over 3, and then the minus 2 is out here, right? You've got to do this in the correct order, guys. You've got to undo things in the correct order. Questions? Concerns? Okay. Awesome. We're going to do well. Okay, so you'll do the test review, guys. If you do this test review, you will do well on the test. If you skip problems and don't finish it, you probably won't do well. My tests aren't going to surprise you. If you can do the test review, you can do the test. They're not going to be the same problems, but the same type of problems. If you ask anyone who's taken my class before, if you do the test reviews and you actually understand them and you know you're getting them right, you should do well on the test. So I would make sure that I cover, while in class today, a couple off of every section. So I would do a couple in solving, and I'd skip over to the simplifying, skip down, I'd get to the second page, I'd get over it so that I can help you on all of it. Does that make sense, everybody? And then I go home and do some homework. Ready, set, go.